Hi, everyone. Could you do me a favor and take a seat? If some of you guys who are here could do me a favor and get closer to this side because there are long lines and I'm trying to clear this area so that the people that are going to be coming in the next 10 minutes do not disturb the speakers. Could you do me a favor and just move a little bit? Okay, so welcome everyone, and sorry for the slight delay. It sounds like the lines downstairs are unusually bad, but we're going to jump right into it. So we have two spotlight presentations of startups before the VC panel. We're going to be starting with Jeff at Precog, and the next one will be Max Yankelevich from Crowd Computing Software. So without further ado.
Thanks. We on? Yeah. All right, thanks, Matt. I appreciate the opportunity to be here today. My name is Jeff Carr. I'm the CEO at Precog. We're an early-stage company based out of beautiful Boulder, Colorado. I'm here in New York for the Strata Conference, so taking advantage of the time. And I walked in and saw one of the few people I actually know who's the next speaker, Max. So also funded by RTP Ventures. So we're going to talk a little bit about Precog and explain sort of what we're doing and why we do it and what our sort of mission in life is. So I'll try to move through it quickly and leave some time for Q&A. So our tagline is productize big data, and what we mean by that is there's a lot of people out there right now that are figuring out all kinds of different ways to sort of capture it and store it and analyze it and do all kinds of things with it. But ultimately, the whole purpose of it is to be able to turn it into useful products and features and things that we can monetize either within existing products and platforms that we already have or create entirely new ones. And to do that today is actually a fairly difficult process, and I'm sure probably 95% of the people in the room understand that. Let me move forward here. Sorry, this is a bit of an eye chart, but again, I think probably most of the people in the room are looking at this and probably imagining they have something almost exactly like it somewhere sitting on their machine back at their office. This is sort of big data today. And I don't in any way want to sound like this in a negative way. We're just sort of showing you, and the founding of our company actually came out of a project just like this, where one of our founders was working for a company in the social media space. And they said, hey, we want to monetize all this data that we're capturing, all this measured and event-oriented data. So he started off on a project to do that and essentially built this. So for people in the back that maybe can't see real well, on the left-hand side is event-oriented data that we're all familiar with in large volumes of it, clickstream and transactions and content and things like that. And then it ends up getting dumped into some sort of file system. Hadoop obviously is one of the more popular ones, but it can be lots of other things. And then we start massaging it with things like pig scripts for munging and Mahout for machine learning and Hive and doing things like that. And then leading into some sort of ETL process that ends up being dumped into different types of structured databases like RDBMSs or things like Redis is a way to be able to start doing analysis. Because doing analysis natively on a file system like Hadoop is extremely hard. It's very difficult to write the jobs, and they tend to run incredibly slowly. So you move into that phase. And then kind of over here in the middle, we've got the whole data analysis or data scientist or statistical analysis piece of it. And what that really ends up being is data scientists sitting around trying to create analysis models that are interesting and come up with predictive models and things like that. The problem that you run into with that is that actually doesn't translate very well into the big data world. You can use tools like MATLAB and SPSS and R and those sorts of things, and you could build really cool models with them. R is an incredibly powerful language, but it doesn't translate well. It doesn't work in big data, and if you want to run that in an actual application, you then start over and basically hand code it in Java or whatever language you're using. So the point with that is that it's doable. It's just really complex. It's a very long, drawn-out process to create even basic new features to monetize all of this data that you're capturing. So the idea behind Precog is how can we actually create a process and a platform that will greatly reduce this process and compress that cycle and essentially make it much easier to do this. So that's essentially what we created with Precog. So I'll explain kind of what's in there and how we go about doing that. Now, two things I want to clarify here. You can dump data directly into Precog. It is a platform. It is a cloud-based service. It doesn't require, the data that goes into it doesn't need to be structured in any way. It doesn't need to be normalized. It doesn't need anything. You just dump it in there. And there's different ways you can do that. We've got a really wonderful set of APIs. But you can also have it staged in something like Hadoop. So if people in the audience are saying, well, I've already got a ton of stuff sitting in Hadoop, we're not suggesting you throw that all in the harbor and get rid of it. We have synchronizers for Hadoop and other data stores and file systems that you can move stuff in and out of very efficiently. So you have the opportunity to dump it in there. And then what happens inside of Precog is it's captured. We provide very robust APIs to allow you to augment that. So if you want to bring in third-party data, so let's say you have a bunch of unstructured data and you want to enrich it with maybe some location data or some sort of demographic data, we make it very easy to do that. We then store it, and then we allow for analysis and deployment in a very compressed cycle. And I'm going to explain that. And I apologize, I pulled a lot of this from a presentation I was doing at Strata because I kind of found about this last minute. So I know it's a little hard to read, but all I'm showing you here is basically, this is a mythical company we call Rollins, which is an online automobile platform for selling cars and doing reviews and all that kind of stuff. So this is their application. So what we're showing basically here is that they're creating essentially a placeholder for what will amount to be an API call to the Precog platform for a predictive model to sell somebody a car. And this is our interface. And again, a little bit hard to read because of the contrast on the screen, but this is lab code. So lab code is our analysis layer. And it is based on a language called Quirl. Quirl is a statistically oriented query language. So we call it big data for R, or R for big data. So it does the same types of things. It's not a full-fledged programming language like R. It's not as powerful, but it's extremely simple to use. It's purely declarative. It's implicitly parallel. So everything that you do in Quirl is automatically parallelized across n nodes. So what you're looking at is you've kind of got a query planner in the middle. You've got a file system metaphor where it's actually going to be able to access all of the data that you have stored in Precog in a file system way. So you could have that set up by customer or by application or however it makes sense for you. You've got a query manager down here. And you can create very powerful statistical queries. And there's a wonderful tutorial. And I will say right now that Precog, you can actually go to our website, precog.io or precog.com, and there's a button that says play with lab code. And you can actually go in and do, if you're a data scientist, you can have tons of fun with this. You're only going to let you put a little bit of data in there, but you can have lots of fun and you can learn how to operate a very powerful language for doing very interesting, iterative, complex analysis. But then what's interesting is you can then, once you create a model you like, so let's say you build a statistical model, you iterate it several times and you create something you really like and say this is very powerful, you can then directly export that as usable code. So we've got libraries for JavaScript, HTML, PHP, Ruby, Python. We're adding them constantly. So regardless of what your application's built in, you can actually take that query that you just created, export it, and paste it right back into the application. And this is just sort of a mock of the application. And so in this case, we're making a recommendation. We're saying, based on everything we know about you, from all of the data that we have, whether it's data we captured or data that came to us through a third party or however we got there, we're recommending you do this. The point of that is all this is doable today. We all know this because companies do it every day. People like Amazon and Netflix are really good at this. But you have to understand, they spent millions and millions and millions of dollars getting there, and they have hundreds of people and data scientists and massive amounts of infrastructure to do it. So if you're a smaller company, an early stage company, or somebody that just wants to be able to create new features and applications very quickly inside of your application or entirely new applications, Precog allows you a very flexible way to do that and just compress all of those cycles down. And obviously, as a platform, it doesn't require, you're not going to build, going back to that eye chart we had at the very beginning, you're not going to have to build this massive big data infrastructure to do all this. So in the current, what we call sort of the current method, or sort of this, the current, I'll say, conventional wisdom behind big data, it can take weeks to months to build those kinds of applications, what I just showed you. And with Precog, you can do some of these. We've had people actually create applications in hours and deploy them, using very complex models. So just to give you a quick look at what's under the covers, and then it'll leave us a few minutes for Q&A. So again, from a data standpoint, any data source, we don't care where, how it comes in, it can be streamed in, it can be batched in, structured, unstructured. We don't expect you to have any particular structure behind the data. Lab code is our analysis or our query layer. Complex statistical analysis, it's again based on a language called Quirl. It's quirl-lang.org if you want to look at it. It is an open source specification. It will allow you as a data scientist to do some really powerful models, and it's very easy to learn. Most people, if you're already familiar with SQL or R or things like that, you'll actually be able to learn the language in about 2 hours. And then we do have a layer on top of that we call Report Grid, which is actually a beautiful HTML5 application of visualization library and a report builder. So if you want to take it that next step, we've actually got a customer here in New York that uses it to create some really, uses Precog to create some really interesting graphs that they just embed inside of the application that they have. Theirs is a geolocation application, so they're just using it to embed things like heat maps and things like that inside of it. And then, as I said, on the application side, we support multiple different client libraries, so regardless of what your app's built in, we can either support it today, or probably if we don't have support for it, we can have support for it in probably a couple of weeks, because we add client libraries all the time just based on need. So that's the basic concept behind Precog. It's the idea of being able to, rapidly develop and deploy meaningful applications leveraging the big data. A lot of people are talking about analyzing big data today, which is great, but if you actually analyze it and come up with information that you find useful, wouldn't it be nice to be able to actually turn that into some kind of revenue-generating piece of application or new feature or something inside of your platform? And that's really the point of what we're doing. Like I said, you can go to our site, you can provision a free account. It just holds a little bit of data, about 100 megs, but it'll give you a chance to play around. You can play around with lab coat without even provisioning an account. You can just go in there and mess around with some data we stuck in there on the website. So that's Precog.
Great,
Q&A.
thank you very much. Why don't you have a seat and we'll take some questions from the audience. So we should have mics somewhere. Okay, who wants to get started, and I'll give you mine. Anyone?
Okay. Since we're hosted by Bloomberg, how does it work with market data, real-time streaming price data, things like that?
When you say how does it work, give me an example. What do you? Sorry.
Is it a particular interface for price data, things like that arrive continuously and unpredictably?
You can stream data into Precog. The API supports streaming, asynchronous and synchronous data streaming. So we don't. Again, we're not tied to any particular data source or format or anything like that. So it's basically whatever you can do with the API.
Thank you. There is a mic now in the back. If you guys have any other question. Yes, no? Okay, well,
Since you mentioned Netflix and Amazon, have you ever tried running it against like the Netflix prize data or any of those things, since they have that out there anyways?
We haven't. We have run it against a variety of different sort of readily available data sets and stuff. We haven't done anything with the Netflix data or anything like that. We haven't, we've built a few applications on top of it, but most of what we've done is actually building the platform. We haven't gone the next step, although we're hoping that some people like you will do it, so with their free account. So grab some data, dump it in there, and start building stuff.
Be careful what you wish for.
Fair enough. So.
Good.
All right. Well, thanks.
Thank you very much.